Today I am joined by John and Shirin from the MBCC Group to talk about concrete and how companies can reduce their CO2 emissions by using admixtures within concrete.
Hi, I'm John Ortiz. I'm the head of sustainability for MBCC Group.
I'm Shirin Fataei. I'm Global Sustainability Manager for MBCC Group.
What does the MBCC Group do?
So we're a global supplier of construction chemicals. Our products and services provide solutions to many of the challenges associated with construction and the built environment. We have over 130 sites in 70 countries and employ nearly 7,800 employees around the world.
What are the core values behind MBCC Group?
Yeah, I'd say, we're solutions oriented, very customer focused. Innovation is at the heart of our business, and with that comes advancements and improvements in the sustainable the sustainable benefits that our products provide to the construction industry, and concrete in particular, amongst other things.
What are some of the innovative and sustainable products and solutions you provide for various industries?
So basically, we try to have answer for anything you might ask with regards to construction industry. We have a really huge portfolio, but if I want to divide it, I can say there are two categories. We have construction solutions, and they are things that you can find around yourself, like this shiny floor in a parking lot. They are construction solutions. If you want to build, I don't know, a wind turbine farm, then we provide grout for the foundation. So you can find our construction solutions product everywhere. You can use it like to glue your tile in the kitchen. And then we have concrete admixtures. So this is another category of our product. And these are basically chemicals that go inside concrete and gives you specific properties.
From your 2021 sustainability report, what needs to be done in order to reduce CO2 emissions?
Yeah, so I'd say we look at climate and the environment in two ways, and one is the impact of our operations and manufacturing operations and presence of our businesses. That's kind of one piece of it, and then the other piece of it is what our products do in the hands of customers. So the positive benefits that our products bring, and so we've set a number of fairly short term goals to make sure we're on track. They're not 2050 type goals. They're actually 2025. We plan to have 60% of our energy sourced from renewable sources. We'll have a reduction on a product intensity basis of 15% in terms of energy consumption, water reduction, and waste reduction, and so that's our own internal operations, right? Our own footprint reduction. So we're taking steps there, and then the way our products interact with customers, and we're gonna get into a little more detail on that. But our products bring some pretty significant benefits to the construction business by reducing the carbon intensity of key building materials.
From your 2021 sustainability report, what does your sustainability strategy outline?
Our sustainability strategy has 4 pillars, and the first one I mentioned is sustainable products. Again, what our products do in customers' hands in the built environment, in the construction industry. Our climate and the environment, which includes both our internal operations as well as what our products are doing and innovation in those respects. Employees, that's our employees, how we treat our employees, how their safety, their health and safety, their employee engagement, and then business integrity, which is a pretty holistic view of sustainability in general, is covering those four areas.
What does your sustainability approach consist of?
John talked about sustainable products. So we are, first of all, we are promoting. So we know which part of our portfolio has higher impact on environment, like which part can bring more sustainable solutions to the table. So we are deliberately pushing this product and we are advertising this product and we have this series of product and we are educating the public about this product. So this is something we do. We take a look at our supply chain, at our production facility, how we can improve our portfolio, because what we do is chemistry and chemistry can always be optimized. So there is no end to that. And this is what we do as well in our R&D. We have a really strong R&D, I have to say, in comparison to our competitors.
Looking at it in two ways, like Shirin just mentioned, our own operations. And for there we actually have a fairly ambitious renewable energy program, and we're weighing different options of on-site solar generation, renewable energy purchases, and energy efficiency, right? Which kind of builds into any program. You start with efficiency, use less, and then convert that less consumed energy into a renewable source. So that's kind of one aspect of it. And then Shirin has said, I think the industry doesn't have a full awareness of what you can do, and I shouldn't say maybe the industry. It's more of customers of the industry don't know that they can ask for concrete that has a lower impact, and therefore they don't. So part of what we're trying to do today and want to do is make people more aware of, you actually have the ability to specify lower impact concrete, and we'll talk a little bit about how much impact or how much benefit you can gain later, and the numbers are pretty startling. So we want that these are solutions that we can do now, right? So everybody's talking about net zero and 1.5 and 2.0. Like, we have solutions to help companies get there today, right? You don't have to wait until 2050 to reduce your carbon footprint. You can actually start doing that and start marching down that trajectory now.
Why is concrete important for climate adaptation?
And adaptation is one aspect of it, right? So concrete's the most used man-made material on the planet, and you see it everywhere. You're probably in at least a concrete foundation. You drove past concrete, bridges and barriers on your way to work. It's everywhere, right? It's ubiquitous. It's critical in many applications. In terms of adaptation, we think about adaptation is how do we react to a changing climate, and amongst those solutions, things like seawalls, better storm drainage, as Shirin mentioned, wind turbine grouts and wind turbine installations. Those are all things that we're doing to adapt to a warmer planet. Concrete is going to be part of that. What we're really excited about is concrete also has some pretty significant carbon intensity values, and our solutions can actually help reduce that again today, right? So before those buildings and those structures are made, you can start with a lower impact concrete. And again, we'll talk a little bit more about that. But like I said, one is it's everywhere. Two, it's got a pretty high carbon content or embodied carbon content, and that's why it's important from you need to have it. It's not going to go away, but you also need to be more responsible with how you use it.
Concrete is the thing you see in the house. It's the stone that made the walls and everything, the foundation, and as John said, it's everywhere. So concrete people see. The problem is cement part. Cement most people don't see. Cement is like a powder, and then you mix it with water, and then it gives you something like a toothpaste, like feeling wise in your finger is like toothpaste. Then you put sand and aggregate on top, you mix everything, you let it stay, and then it makes a rock. So the biggest embodied carbon in this concrete comes from the cement, which is something it's like a flour. that you make cake with. Same, so it's a powder. And the problem is when you're producing cement, you emit CO2 for two reasons. One reason is because you need to heat the limestone. This is part of the process. And that heating will generate some CO2, will emit some CO2 depending on the source. Another part is the decomposition of limestone. When you break the limestone to take the most essential ingredient of cement, at the same time, you release the same amount of CO2. And that CO2, unfortunately, goes to the atmosphere and then emit everything. And that's the problem. And this is something we cannot avoid by, moving to a green energy. This is coming out of the core of the material. To solve that problem, of course, people try to look for solutions. And one of these solutions is, for instance, carbon capture, use, and storage. And everyone talks about it. But the problem is, and many researchers are trying now to point this out to the public, the problem is that such solutions are expensive. You should do it for sure. I'm not neglecting that. I'm not disregarding this point. But they are expensive. You need to modify one plant at a time, which means you cannot snap your finger and say, everyone now green and everyone is now sustainable and we are all pretty. That's not gonna happen. You need time. It will take us a few decades until we reach that point. And what we would like to communicate to public and what we are trying to educate people on is that if you use admixture, if you try to optimize your current mix design now, you can already reduce 25% of your CO2 emission. You can start making this decision and doing it today. And this is where admixture can play a really significant role.
What are admixtures and what are the benefits of its application?
Yeah, I like to think of admixtures as little sprinkles of magic for concrete. So we use admixtures. Admixtures have been around for quite some time, and they're there to make cement more workable, right? So the different applications of cement, flooring, buildings. You pump it to the 30th floor of a building. Those kinds of things require workability, require fluidity, and so admixtures enable that. But at the same time, admixtures also allow the use of other materials and less what we call clinker. And that's the cement that Shirin was describing before, right? So that cement, highly carbon intensive, also the most expensive element of concrete. But we actually enable to use less, right? Use less and use alternative materials that have a lower impact on the environment, and still perform without trade-offs. So I'd say that's the kind of the big picture for admixtures. And again, I call them sprinkles of magic. Shirin will get into the chemistry and application of them with quite a bit more detail.
I call it baking powder of the cake because you put a little bit and then your cake becomes so delicious. So each of us have our own our own interpretation of admixture. Mostly people know admixture for improving workability, and I can tell you what workability is in short. So when you mix this cement and water, and I told you will have a glue that glues everything together, you have a specific open time that you can work with this glue, with this concrete, fresh concrete, and afterward it becomes so stiff that you cannot change it anymore. So what I say admixture because it's only one category of admixture, but people usually associate the whole admixture only with this one category because it's the most famous and important one. This water reducing or super plasticizer type of admixture, this sub branch, what they do is they increase or decrease this working time. So you can pump the concrete for 2 hours if you are pumping for a skyscraper, or you can pump it longer in a tunnel. Then sometimes you have to pump 1 kilometer because they started from the beginning of the tunnel and now they're 1 kilometer in. So you have to deliver that. Sometimes you are using digital fabrication. So this is in direction of Industry 4. that we have digital fabrication, and a lot of people now heard about 3D printing. It's a trend. And for instance, with 3D printing, you print one layer of concrete at a time, and then you go up and then you form a wall. The point is, when you print it, when it's coming out, you want it to be deformable. You want it to be like a clay in your hand and take a shape. But as soon as you want to put the next layer, you want it to be stiff enough to carry the next layer. So it needs to be everything at the same time, flowable and then harden quicker. So these things are, you can do a bit of mix optimization, but at the end of the day, you need that mixture. You need this water reducing, this super plasticizer and accelerator to be able to manipulate the chemistry, the traditional chemistry, to manipulate it to the modern wishes, if I want to. And this is something Admixture do.
And you need expertise like Shirin and our huge sales force out there that actually helps customers design these solutions and meet all those needs that they have. And so that it isn't just about chemicals you throw in there. It's about the expertise to apply them. It's the expertise to find the right balance, to adapt to your own material set that you're bringing perhaps locally. Like all these kind of factor into getting the mix right, and of course we use concrete to build things that are important to us, like houses and buildings and parking lots and structures that we want to be safe and not have to worry about 25, 30, 50, 75 years from now. All that has to be factored into that mix design. And again, this is where our chemistry and our expertise brings that to play.
How do admixtures solve today's climate-related challenges?
I'll try to break it into four things, and the four things we've talked pretty well about CO2 reduction, right? So again, and that comes from using less cement, using less what we call clinker, and that reduction is pretty huge. And Shirin will give you a few more statistics on projects that we've actually done, but it's today, conservatively, it's 25%. It has the possibility of reducing the CO2, embedded CO2 of concrete by as much as 50%, with the right environment, the right applications. That's one. The second one is water reduction. So primary use of admixtures is to use less water and still continue to make it flowable, like Shirin described. So that's another. That's really important in water stressed areas. It's really, water is a precious resource that we can't afford to squander. Waste reduction is the third one, I'd say, and that comes from a couple things. So the typical process of building things is you estimate how much concrete you need, it's delivered, and maybe you guessed wrong. You either guessed too much or too little, and the truck has to come back, and then you have waste at the end of the day. That can't be. It doesn't get saved. We have mixtures that actually help you use that material the next day without any trade-offs. The other is, being able to use or recycle building materials that have been torn down. So those materials without help, right? Without help from a chemistry solution, really are not attractive to a builder. They want to use fresh aggregate, fresh sand, etc. So we have the tools to do that. And then the fourth one, I call it a bit of a trifecta. There's a class of concrete that we call precast. There's an industry, or there's at least a series of companies that are out there that create precast. And precast, you drove in past barriers on your way to work today. Those are all precast concrete, right? So they're built in a factory. It's essentially a mold. Cement is poured in the mold. It's cured. Well, in that process, you typically use heat to cure it faster so that they can get more productivity out of it. So we have admixtures that again do all the things that we've said before: reduce water, reduce the carbon intensity of the concrete itself, and not have performance trade-offs, and then reduce the amount of heat you have to add to cure it. So you get this trifecta of environmental benefit. That last one we're still working on quantifying. So, but we have some customers that are actually going to measure that impact for us. They know it to be true. They buy our materials because it also helps save them money. But now we want to quantify that. So that's a project we're embarking on here pretty shortly.
What about your company and sustainable concrete do you want people to know?
So I'm going to use one word, and the word is now. And then I want Shirin to talk a little bit. But this is about making choices now, right? Choosing a concrete mixture that that reduces your impact on the environment, and doing it now.
John said earlier, we had, for instance, recently a project in Berlin, and there are some posts about it. You can find on our website as well. That we could, or the designer could, at the end of the day, reduce 50% CO2 emission by optimizing the design, the construction design, the mixed recipe, and then they brought so many things together, and they could reduce by 50%. And we did some studies, and actually there are some research on this. And let's say we cannot do always 50% reduction, because that needs a lot of work. Maybe you need to talk with construction designer, you need to talk with many people. But simply coming only from concrete plant, you can easily reduce 25% CO2 emission. Like, you use admixture, it allows you to have the same workable concrete with the same properties, with the same end properties, but with 25% less cement and clinker, which means 25% less CO2 emission. And this can be done with a snap of a finger. You just need to ask. You just need to go to the concrete plant and ask for it. You need to say, I want low carbon concrete. And then let me give you something to visualize it better. If all the concretes that are produced annually, and this is about 14 billion cubic meters, it's a lot. If all of them decide to produce this low carbon, to produce this optimized concrete, and they all reduce 25% of cement, then it's equivalent to removing 180 million cars off the road annually.
That's correct. Yeah.
If I want to make choices, I would go and ask for low carbon concrete. And I think this is something anyone can do. And this is something that already is in progress in northern region of Europe. So in somewhere like Norway, you have to, like, the concrete plant have to only provide low carbon concrete. They cannot anymore provide these traditional high cement content concrete anymore. They have to do better. And this is something that will come to the rest of the world as well.
How do your solutions help companies and businesses address their Scope 3 emissions?
Yeah, that's a good one. So Scope 3 is everyone's challenge right now. And I don't want to go through, but it's we're working on our Scope 1, 2 emissions, and plan to work on our own Scope 3 emissions this coming year. But everyone is in the same place, and what COP26 and COP27 both focused on was carbon emissions and how do we get there. And you really don't have a credible global climate policy or program if you're not addressing your Scope 3 emissions, because it ends up, if you're a product related company, it's 80 to 90% of your overall emissions, right? Scope 3 is your value chain, everything in your value chain, how products get to customers, how materials get to you. And so, your typical approach as a company is, let me look at my Scope 3 emissions, let's measure it, baseline it, and then you put everything on a pie chart, and you look at what are the biggest elements of my Scope 3 emissions, and then you start with those, right? You have to prioritize. Well, in a product company, and the product could be a building, could be a road, it could be anything. It's going to be the materials you buy, and we have a solution that actually helps you reduce those emissions by 25 to 50%. So we can do that. Again, it's back to now, right? You can use our material, use our products, use our materials, and there's other admixtures on the market, so we're not exclusive. But you can do this now by specifying it, as Shirin said. And I think the only other thing there is, I get, as head of sustainability, I get 2 to 3 calls, 4 calls a week from software providers. Hey, we can help you measure your Scope 3 emissions. But without me asking, not one of my suppliers has come to me going, hey, I have a product that can actually help you reduce your Scope 3 emissions. that's what we have, and that will be part of the what we want people to understand is, hey, you actually can target your scope 3 emissions right now, have measurable differences and changes today. And again, the traditional approach of, well, let me look at my biggest elements within it might not work. You actually have to look at all of it and say, okay, as a system, this concrete solution can be reduced by adding 2 to 3% of an admixture, again, sprinkles of magic, and use less of the other higher offending material in your mix. And that's, so again, it's a little counterintuitive. Something that you use very little of actually can impact what you use in other products. And again, I think that's where we can help.
And there is something that I hear most people, when you hear about sustainability, I'm sorry to interrupt you, but when you talk about sustainability, a lot of people think like, oh my God, it's going to cost me more. I don't know, like vegan meat or vegan milk or whatever. And then with this specific case, because we are reducing the amount of cement, and cement is actually the most expensive component in concrete, you are not necessarily increasing the cost. You stay by the same cost, more or less, or maybe even less, I cannot say for sure, but definitely not, you're not increasing cost intensively. You will stay the same. In the worst case scenario, you're going to stay the same cost. But you will improve a lot on your CO2, as John said, on your scope 3. If you are a precast or ready-mix concrete, it stands for you. If you are a construction company that is building houses, it will fit in your scope 3. Somehow, all of us are entangled together, and if we all work better, if we try to improve what we ask and what we are producing, then at the end of the day, in many places we can cut emission. And I think such a stuff has been done already in many other industries. I always tell you that, for instance, in car industry, they already improved automobile industry so many times to make it better, more efficient, faster, like aerodynamic, this and that. But somehow with concrete, because it's always there, it turns into stone, and afterward you don't think about it anymore. Nobody, sometimes not, no, some people do. I'm sorry, nobody is not true, but few people would think, let me make it better. Let me go one step more. I mean, research is always working on better solutions. They are really nice researchers, globally working on this. But industry, research is always small. You need to change the mind of industry to do something innovative, to go that one further step for the future. And I think this is somewhere we can help a lot.
I think collaboration is a really key part there. And, as I mentioned before, you don't just buy things off the shelf and throw them in your concrete mix. You actually rely on our team's expertise to help you get it right, so that you're not jeopardizing people's lives with poor structures, but you're actually making the right choices and doing it without trade-offs. So again, that collaboration is key. That's what we offer, and that's what is part of that whole value chain of what makes up Scope 3. So.
What are future plans and goals for MBCC Group in addressing climate issues?
First, we are looking at our own operations. We're looking at our own operations. We have a pretty aggressive renewable energy target for 2025 of 60% of our energy used. We're looking at our wastewater and also energy efficiency, and then the other thing, but where we'll make a bigger impact is getting this message out, and getting more water saving, clinker saving, or clinker reducing admixtures out there, and influencing standards and regulations to enable enable and promote the use of lower intensity concrete.